Okay, welcome back. And last but not least, we have division with exponents. I'm going to start with a variable, using variables. And let's do x to the fourth divided by x to the second. Okay. Both of the exponents are positive, so I don't have any negatives to deal with. Let's write this out in expanded notation. X times x times x times x all over x times x. Now, sometime in the past, you've probably been told that anything divided by itself, x divided by x, is just 1. And when we do division, when something one's out, we call it, we could write 1, but that would be just 1 times all of this. And that doesn't really change anything. So typically, we just kind of cross them off. So x divided by x, those two cancel. X divided by x, those two cancel. And when there's nothing left on the bottom, or it could be on the top, but in this case on the bottom, nothing left to cancel out, I'm done. And that's what I'm left with. X times x, which is x squared. How do I get to an exponent of 2 when I started with 4 and 2? Well, if you think about it, when we multiplied, for instance right here, when I multiplied, I would add the exponents. 1 plus 1 plus 1 plus 1 is 4. And since division is the opposite of multiplication, doesn't it make sense that we do the opposite with our exponents? In other words, wouldn't it make sense that we take the top minus the bottom to give us x squared? The 4 minus the 2 to give us x squared. And in fact, that's exactly what we have. I typically tell students that because we tend to remember the multiplication property, because that's what we use more often, I think, I tend to help them remember by having them think, well, division's the opposite of multiplication. And I know that with multiplication, I add the exponents. So when I divide, I must do the opposite, which is subtract. So our general rule then, a to the n over a to the m, any exponent, is equal to a to the n minus m. Same base, top exponent minus the bottom exponent. So let's try that with another term. Let's try y to the fourth over y to the third. Following our new rule that I just kind of showed you how that's derived, I take, since they're the same base, I take the base of y, and I take the top exponent minus the bottom, simplify it to 1. And I probably will accept that right now in your work, but we should get used to writing it when it has a variable or an exponent of 1 as just y. The 1 should just be understood. Okay, now let's have you try one. Let's do b to the fourth divided by b. See what you come up with on that. I threw a little bit of a curveball at you. Try to remember some of your prior exponent rules. What is this b? What's the exponent on that b? Go ahead and stop the video and write down what you think. Okay. Well, the first thing I've got to remember is anytime I have a variable or a number by itself, I've got to remember that there's that understood 1 right there. And since these bases are the same, that base is going to be part of my answer, and I have 4 minus 1, top minus bottom, to give me an exponent of 3. Okay? Let's look at something a little bit different. Let's try y to the 3rd over y to the 7th. Okay? Well, if I simply follow my rule, the base of y, now some students are going to want to take this minus this, but I've got to keep to the exponent on top being my first term here. So it's the top minus the bottom. And I think why students take the bigger minus the small is because they want to end up with a positive number. We got to stick with the rule here. And 3 minus 7 is negative 4. Okay? A lot of students might get here and think they got to stop, but remember what we said about negative exponents. We don't want them. We can still simplify further. That's 1 over y to the 4th. There's the final answer. Similarly, I can use this rule with negative exponents. It works just fine. Let's try x to the negative 5th over x to the negative 3rd. Well, how's that going to work out? Well, I treat it just like an algebraic expression. Keep the same base, and I have negative 5, I keep the sign, minus the negative 3. Okay, now remembering back to your, in my classroom we don't usually do subtraction, we change it to addition. It goes same, change, change. This sign stays the same, change it to addition, change the sign of the next term. So it turns into negative 5 plus positive 3, which equals x to the negative 2. This is an okay answer, but I've got to get rid of that negative exponent. So why don't you try one with some negative exponents here. Let's do x to the negative 5th divided by x to the 10th. Okay? Stop the video, follow the procedure, go back if you have to, but write down what you think the answer is going to be. Okay. Simply take my base, take the top exponent minus the top or bottom exponent, and it's negative 5 minus positive 10 equals same, change, change, and that's going to be negative 15, x to the negative 15. Don't like the negative sign. Final answer. Okay. Give this a shot on your entrance ticket, and we'll work on a little bit more complicated ones tomorrow. Have a nice day.